Welcome back. In this lesson, we're going to start looking at igneous rocks. Igneous comes from the word fire, like we get the word ignite. So an igneous rock was once a melted rock. So a melted rock is going to be under the earth deeply, very deeply, or close enough to the earth that some of that melted rock could come out in the form of lava. So we're looking at volcanic rocks. So if I were to say volcanic rocks and igneous rocks, I'm really talking about the same types of rocks. A volcano is on the surface of the earth, though, and not all igneous rocks make it out to the surface. Some cool down very low under the earth, and then later, by different forces, are brought up that can then be mined. So it depends on how quickly something cools as to what kind of it shows up as. But anything that was melted, anything that was once magma, is considered igneous. So let's look at some of the examples. So igneous comes from the word fire, and the fire would be coming from a volcano. So an igneous rock was once melted rock that has either come out of a volcano or was once in the deep area under a volcano. So magma is the term for molten rock, and lava is the same stuff as magma, only it's come out of a volcano. So as long as magma is still in the ground, molten rock is still in the ground, it's referred to as magma. If that magma ever makes its way out of the earth and out of a volcano, then it's called lava. Normally we consider lava to be the liquid form of rock that's coming out of a volcano, and then once that lava has cooled and hardened back into a rock, we refer to it as an igneous rock. And you're going to see that there's various types of igneous rocks that either made it out of the volcano and cooled very quickly, or rocks that stayed deep in the earth, was melted at a time, but then the heat was removed and it cooled back down and solidified into a rock. So it takes about 1,000 degrees or so to melt a rock. It depends on what type of rock it is. The more heavy materials, heavy elements, say iron or something that's in a rock, will make it melt at a much higher temperature. Other rocks could melt like 700 or 800 degrees would melt a rock. So the composition of magma is different everywhere. Normally, the rock that is being melted is going to determine what's in that lava. Once it's melted, it was melted from different types of rocks. So different volcanoes are going to have different compositions of their lava based upon their location. Their location is what the rocks around that location is made out of. As they melt, they'll either be melt at high temperatures or low temperatures, or have this composition or that. And so you're going to classify magma in three basic ways, usually based upon the amount of silica. Silica, remember, silicates is silicon and oxygen. Most of the Earth's crust is made out of silicates. That means most of the Earth's crust that's melted underneath the ground is going to be silicon and oxygen. And so the more silica that you have, the thicker the lava becomes, and that's called viscosity. Viscosity is the thickness, or like syrup is more viscous than water. It's sticky and flows slowly rather than quickly like water would flow. So when you have basaltic lava, it is really thin. It has low silica and is runny. And so you're going to have like volcanoes in Hawaii, that's all basaltic lava. You're going to see that the crust of the ocean is very low silica content. And so when it melts and turns out as lava, it's runny. And this is a picture here of a runny lava, Hawaiian usually lava. As the silica content increases, you get andesitic, and then the final one would be rhyolitic, very, very thick. Now it normally explodes because it's so thick that it doesn't want to flow, and pressure will build up, and usually that kind of a volcano that has rhyolitic lava will blow its top, usually explode. You're going to see that there's other stuff in it. You're going to have gases dissolved in it, and usually different types of minerals also dissolve. So a mineral that maybe wouldn't have melted at the temperature of that lava will still be a crystal, or maybe it had crystallized as that lava was cooling off and it crystallized. So the lava is going to have different stuff in it. It's formed in different ways. It's melted, okay, so that's what magma is. It's molten rock. And so as your temperature increase, usually you're going to get a more magma. As the pressure increases, you'll normally have more magma. So the pressure increases the temperature. The more water content it is will determine whether rocks melt or doesn't melt, and then what those rocks are made out of. The thicker rocks or thicker minerals, higher melting point minerals will determine on whether a certain pressure or temperature can melt that rock. This is called the Bowens Series, or the Bowens Reactant Series, and I like Mr. Bowen. He was a professor in, I think, Chicago back in the early 1900s, and he studied lava. And he realized that certain rocks that everybody can dig out has different amounts of silica. So olivine is going to have low silica, and then pyroxene higher, amphibole higher, biotite mica higher. And so as the temperature drops, as it cools down, so you can see, so as the temperature gets lower, you're going to get these rocks starting to crystallize out. So olivine comes out first because it's the smallest, so it crystallizes as the temperature is still rather high. As the temperature is dropping, olivine comes out first, crystallizes, then pyroxene. So when the temperature is really, really high, all of these are melted. And then as it drops, the littler guys will come out first. So olivine is basically just the tetrahedrons, silicate tetrahedrons. Then as it cools down more, the chains will come out, the single chains, the pyroxenes, then the amphiboles. Once it gets to the biotite micas, you're now in the sheets. And then once you get into the quartzes, the micas and quartzes, you're starting to get into the 3D structures. So the more complicated things take longer to cool. And then he's also realizing that feldspars react a little bit different than that. Feldspars are whether they're full of calcium or full of sodium. So as the temperature drops, more and more sodium comes into feldspars, and so you end up with different types of feldspars. You could have a dozen different kinds. As it cools down, whatever cools will be that kind of a rock. And that's called the Bowens Reactant Series. And then the last thing is partial melting. So you're not always going to melt something at a certain temperature. So one crystal might be melted, the other one might already be come out. So in any temperature of magma, you're going to have different things, a partial melting where you're going to have some solids and then the rest of them is liquids. And so that means that just like they melt in a certain order, they're going to cool in a certain order. So if you start heating up rocks and start melting the rocks, the little guys, the olivines, for instance, will start melting first. Then the pyroxenes, amphiboles, and the biggers take higher temperatures to melt. Well, then when it cools, it's backwards. The big guys will cool last, and the little guys will cool first. So it's based upon the size of it, and we'll look at a little bit of it more later.